Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is divide in incremental groups. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. Okay, so let's get started. Here is the problem statement, and it says that given two integers n and k, the task is to count the number of ways to divide n into k groups of positive integers such that their sum is n and the number of elements in groups follows a non-decreasing order. Okay, so one example is given here. Let me explain the example. So example says that you have n equals to 8 and k equals to 4. So you have to divide this 8 into groups of size 4 such that like the sum of element is equal to n and group follows a non-decreasing order. Okay, so I can write this 8 I can write this 8 as 2 plus 6, or I can write like 1 plus 7, or I can write like 3 plus 5, or there are multiple possibilities. So I can also write this 3 plus 5 as 1 plus 1 plus 1 plus 5. So this will be something which is equal to 1, 1, 1 and 5. Okay, so now the sum of this group is equal to 8 and the size of this group is equal to 4. So we can have one of the possible groups is 1, 1, 1 and 5. Okay, now one more possible group can be like 1, 1, 2 and 4. Okay, and similarly we can have other groups as like this 2, and like we can have 1, 2, 2 and 3, and we can have 1, 1, 3 and 3. So these are the possibility and the count is equal to 5. So that's why 5 is going to be the output here. Okay, fine. Now I hope you guys have got the clear understanding of the problem statement. Let me talk about the solution now. Okay, so I have to I have a number n and I have to form some groups of size k. Okay, and the group will be of positive integers. Okay, fine. So what are the candidates for the group? Like I can have one in the group, two in the group, three, or I can have four. Or what is the maximum value that I can have? I will say n. Why n? Because uh, I don't want my sum to be greater than n. So that's why maximum value is n that I can have. No any value which is greater than n I will include in the group. Okay, fine. Now I have the candidates. So these are the candidates which are going to include in the group. Okay, fine. Let's call it array. Okay, now in this array, I am going to try out all the possibility to form groups. Okay, so I can have one of the groups as 1, 1, 2, 3, and I can have like 1, 2, 3, 4. So I can have a lot of groups like this. Okay, fine. Let's take I have a group which is having elements like A, B, C, and up to okay, and so on, like as many as possible. Fine. Now in this group, I will check two things. Let's take this is a group. In this group, I will check two things. The first is number of elements and the second one is sum of element. Okay. If in any case my number of elements is equal to k and my sum of elements is equal to n, so I will say okay, this group is valid and I can include this group in my answer. Fine. So till now I hope you guys are clear with what I said. Like I said, I can have a array from 1 to n. So in this array is basically representing the candidates for forming a group. Okay, so after that I can try out all the possible groups which can be formed from this array, and for every group we are going to check these conditions. Fine. Now the question you are going to ask me is, hey, how we can try out all the groups from that array? Okay, so I will tell you. I have array like 1, 2, 3, 4 up to n. Okay, and I can say that I will start from I equals to 0, and for any particular element I that I have, like the maximum value will be I equal to n minus 1. Okay, so any value that I have, like I have currently I'm at this particular 3, so I can either include this 3 to my group. So basically I'm forming a group, so I can include this element in my group or I will not include like this element in the group. Okay, fine. So My answer to the problem, like whatever is my answer, is going to be the total of these two conditions. Like what are the possibility that are there when I include the element, and what are the possibility when I don't include it. Okay, fine. So now I'm going to write it like any problem I can represent as like f of I, sum, and k. I means the current index that I have. Sum means the sum of elements that I have like till now. Okay, and k means the number of elements that I have to include in order to complete the group. Like this, it basically represents the number of remaining element to form a group. Okay, fine. So I will represent my function like answer as f of I, sum, and k. Now, when I include this three, so what is my sum? Sum is going to be sum plus array of I. I'm writing array of I in place of this three in order to generalize this thing. Okay. And after that, when I have included one element, then my k is going to increase. Okay, fine. And I will not change the value of I because like I'm not incrementing I here. Why I'm not incrementing? The reason is if you see this group, then even if you see any of the groups, you will find that we have repeated elements like 1 1 1 is being repeated three times. So I will include this element 3, and after that I will say that okay, in future as well I can include this 3. So that's why I'm not increasing the index. Okay, but when I don't include this 3, in that case I will increment my index. So it will become I plus 1. Sum will remain same because I have not included in the group, and k will remain same. Okay, so this is the recursive relation that we have in order to solve the problem. Now I'm just going to show you the dry run for a particular example. So the idea is to like show you how it is going to work. So I will have an example where I have n equals to 4 and k equals to 3. So I have to divide this 4 into group of size 3. Okay, let me take the array 1 2 3 and 4. So when I draw the recursive tree for this, then the recursive tree will look something like this. You can see that I have the recursive tree here. Okay, and for this recursive tree, okay, let me move this. Okay, for this recursive tree, the first value that I have is I, the second value that I have is like sum, and the third value is k. K equals to 3 means I have to include 3 element, and like remaining element are 3, and sum equal to 0 because I have not included any element till now, and I equals to 0 means starting from this position. Fine. If I take the zeroth element, then my sum is going to increase by 1 because the value is 1. Okay, the remaining element will be 2 now because I have included 1, and the index is not going to increase, same like whatever I have told you here. Okay, fine. Now if I not take the element, then the condition will be something like this. Like I'm going to increase my value of I, and sum and k are going to remain same. Okay, so this is about the recursive approach. Let me show you the code now. Okay, so you can see that on the left hand side I have the Java code, and on the right hand side I have the C++ code. So I'm starting from this point. This is the main function which is going to return the answer. So first of all, I'm making the array which is going to store the element from 1 to n. Okay, and now I'm going to traverse this array. Okay, so I will start from 0, my sum will be 0, and my k will be initially k. Okay, fine. So whenever I include any element, then I'm going to increase like decrease the value of k by 1 and increase the sum by current element. Okay, else I'm going to increase my index. So this is the answer that I'm going to return. Okay, but there are some cases that are needed to be considered. Like if my sum is greater than n, in that case I will return 0 because there is no sense of moving forward. I want my sum to be smaller than equal to n. Okay, and when my k equal to 0, like I have formed a group of size k, so remaining element is equal to 0. Okay, fine. In that case I'm simply going to check is the sum of like group element is equal to n. So if it is true, then I will say okay, it is a valid group. Else I will say it is not a valid group, so I'm not going to include it in my answer. Okay, and one more thing here is like if my I is equal to array dot length, because since I have completed the array, so there is no element to include here. So in that case I'm going to return invalid group because I have not included the k element till now, and there is no more element to include. Okay, fine. The same code I have written here as well. Okay, so now I hope you guys are clear to like the recursive approach. So let me discuss about the time complexity. Okay, talking about the time complexity of this approach. So see what I'm doing. I have an array of size 1, 2, 3, 4 up to n. Okay, and in this array, for any particular element, like for this element, I have two possibility. I can either include or don't include. Okay, so there are two possibility for this, again two for this, again two for this, again two for this. So it is going to multiply with like n times. So 2 raised to the power n is going to be the complexity in order to solve this problem. But this is like a lot of time complexity, and it is going to give me time limit exceed. So what optimizations we can do here? Now, let me talk about the optimal approach. So till now, I want you to like observe one thing, that we have discussed the recursive approach, and with the recursive approach, we have like noticed one thing. Okay, let me change the page. So I'm going to like take the same I'm going to take the same recursive tree again. And in this recursive tree, you can notice one thing, that solution to any problem is depending on the solution to sub problems. So this is something which is known as optimal substructure. Okay, so optimal substructure. And one more thing that you can notice is like these blue colored sub problems. So these are the same problems, sub problems that I'm solving again. So this condition is known as overlapping sub problems. So I have overlapping sub problems. Now this is the condition for like a dynamic programming problem. So whenever we have overlapping sub problems, then I can say that okay, I can apply dynamic programming here. Dynamic programming here. Now how to like apply dynamic programming? You can see that I'm solving the same sub problem again, but my question is there any need to solve the same problem again and again? No, there is no need. So why I'm wasting my time? I can avoid this. How I can avoid this? I can use a data structure which is going to store the solution to every sub problem. So I can have a data structure which is going to like store the like solution for a general subproblem which is represented as this. Okay, and whenever we have a like solution available for any particular subproblem, then instead of solving that subproblem, I'm simply going to return the solution. Okay, so it will look something like, I will have an array which is dp. This dp array is going to have maximum size of n plus 1. And why? Because I have I, sum and k. So what is the maximum value of I? It can be n, and sum can be n plus 1 as well, and k can be k. Okay, so why I'm writing n plus 1? There is a reason, in order to avoid like the array index out of bound exception. Okay, so I'm going to initialize this dp array with -1. Initialize with -1. Why? Because this -1 is going to represent whether a particular subproblem is solved or not. So at any point in time, if my dp of I, sum and k is equal to -1, okay, is not equal to -1, in that case I can say that okay, it is not equal to initial value, means I have solved the subproblem. So in that case, I am simply going to return dp of I, sum and k. Now, this method of like dynamic programming is known as the memoization approach. Memoization approach. Okay, so there is no much to explain about this. I'm simply going to show you the code. So I have the like memoization code here. On the left hand side, I have Java code, and on the right hand side, I have C++ code. Fine. So you can see that there is not a lot of difference between the recursive and memoization. Just the difference is this dp array, which is going to store the solution for every subproblem. Like you can see here, I'm before returning the value, I'm first storing the solution, and after that I'm returning the value. Okay, and this is very important condition which is performing the memoization step, like it is checking whether it is solved or not. So it is the memoization condition. So this condition is going to check if particular subproblem is already solved, then I will simply return the solution to this subproblem. Okay. On the right hand side, you can see the C++ code, and the code is very similar to the one that I have already explained you in Java language. So this is the memoization approach that we have. And talking about the time complexity of this approach, so okay, talking about the time complexity, so we like, what is the maximum value of I that we can have? It is n. So our I value can be n, and after that I have the sum value which is n, and after that I have like the, okay, I have k value. So complexity is going to be of n square k, because there is no any sub problem which is out of bound than this dp array. So whatever is the size of dp array is going to be the time complexity of this approach. Okay, fine. Now let me talk about one more approach, which is tabulation approach. But before that, why tabulation? Why tabulation? The need of tabulation arises when we have something like system stack, which is being used in order to solve the DP problem. So you can see that here my solution is something which is relying on the stack of like the system. So this can cause stack overflow error when we have memory limitations. Okay, so we can avoid this. What we can do is we can have a code something like this. In this code you will notice that we are not making any recursive call. So instead we are like accessing the memory location. So we are having a dp array, and this particular relation is very similar to the relation that we have here. So you can see that instead of calling recursive, instead of having recursive calls, we are accessing the memory location in order to access a particular solution to a subproblem. Okay, and here I'm starting from n, like I'm starting from n and I'm moving towards 0. The reason, because the reason here is, in bottom up approach we always start from base cases and then we move to the solution. So that's why I'm starting from I'm starting for base cases first, and then I'm moving towards the solution. So here again you can see that I have C++ code on the right side. So C++ code is again very similar to the Java code that I have explained you. Okay, so this is all about this problem. I hope you guys like the solution. So if you like the solution, then hit the like button and don't forget to subscribe. Thank you.